Lesson 3.7, we're going to be taking a look at percent of change. Okay, before we get started on our first example, we've got a formula that's going to help us with the next couple of examples we've got. And that is that a percent of change, which is just an increase or decrease, is equal to the amount of that change over the original amount. Okay, so now that we've got that, we can work through example 1. The price of a skirt decreased from $32.95 to $28.95. We need to find the percent of decrease. So percent of decrease, we're going to have the amount of change, and we're dividing it by the original amount. So the amount of change is the starting price, the $32.95, and we subtract the ending price, and that's going to tell us how much it changed, how much it decreased. Then we will divide all of that by the $32.95, the original amount. So when I subtract $32.95 minus $28.95, I find that there's a $4 decrease, and I divide that by the $32.95. That's going to get me 0.12. To change that into a percent, I'm going to move my decimal place 2 places to the right, so I get 12%. So there's a 12% decrease in the price of that skirt. All right, example 2. Between 1940 and 1980, the federal budget increased from $9.5 billion to $725.3 billion. What was the percent of increase in the federal budget? So again, we're going to use the formula that we just came up with on the last slide, where we're taking the amount of change and dividing it by the original amount. So to find the amount of change here, we had an increase from 9.5 billion all the way up to 725.3 billion. So we're going to subtract those to find the amount of change. And we divide it by the original amount, which was the 9.5 billion. We'll subtract, and we're going to find that there is 715.8 billion in change. We'll divide it by the 9.5. That's going to get us 75.35, but that's not our percent of change. To find our percent of change, we need to move our decimal place 2 places to the right. So this is actually 7,535% change. So in a 40-year period, there was a 7,535% change in the federal budget. Example 3, we're reading a bathroom scale as 122 pounds. What is the greatest possible error? Okay, so if we're thinking of a scale, let's kind of draw ourselves a little bathroom scale here. So we've got our little bathroom scale. We need to talk about greatest possible errors. So the greatest possible error on this scale is 1 pound. So it's either going to show us that it's 122 pounds or 121 pounds. So there's an error amount of 1 pound. So the scale is read to the nearest 1 pound. Okay, so most scales, they're read to the nearest 1 pound. Sometimes you'll get a digital scale that might read it a little bit differently. In this case, in this example, the scale is being read to the nearest pound. So it's either 122, 123, 121, somewhere in there. So then our greatest possible error would just be half of that. Because if I get on that scale and I'm really 122.6, that's going to round it up to 123. If I get on that scale and I'm really 122.4, it's going to round it down to 122. If I get on the scale and I'm really 121.7, it would round it up to 122. So the greatest possible error is just half of that pound. So our greatest possible error would be 0.5 of a pound. All right, example 4. When a garden plot was measured, the dimensions were 156 inches by 84 inches. We need to use the greatest possible error to find the minimum and maximum possible areas. Okay, so first we need to figure out our greatest possible error. Our greatest possible error would just be half of an inch. So we want to figure out what our possible errors could be. So for our smallest length, if we had a half of an inch error, our smallest length could be 155.5 inches. Our largest error could be 156.5. All right, similarly for our width, the smallest could be 83.5, and our largest could be 84.5. Well, they want us to figure out what our minimum and maximum possible areas could be. So to find area, we need our area formula, which is just length times width. So then to find our minimum, we would take our smallest length and width and multiply them together. So we're finding our area, we would multiply together and get 12,984.25. And it's in inches. I multiplied inch times inch, so I get inch squared. So that's my minimum. I need to find my maximum by doing the same thing with my largest. So I get 13,224.25 inches squared. Okay, so example 5. Suppose we measure a library book and record its width as 17.6 centimeters. We need to find the percent of error in your measurement. All right, so our error on this one's going to be a little bit different because our measurement is to the 10th. Okay, so we're not rounding it up to the whole number, it's at a 10th. So then our error so if we have a 10th here, our error could be half of this. So our error could be half of that 10th. Half of that 10th would be the 100th place. So half of this. So our error could be 0.05. Okay. So we need to calculate our greatest, or our percentage of error. So our percent of error is our greatest possible error over our measurement. Well, our greatest possible error is the 0.05. Our measurement is the 17.6. When I calculate that, that would get me 0.0028. Well, to turn this into a percent, I want to move my decimal place over 2 places, and I want my answer as a 10th. So I would have to round that 2 up to 3. So my percentage of error here would be 0.3%. Right, example 6. A small jewelry box measures 7.4 centimeters by 12.2 centimeters by 4.2 centimeters. We need to find the percentage of error in calculating its volume. Okay, so first we need to find the percentage of area, or percentage of error. Well, again, these ones are all to the 10th place. So half of a 10th place is going to be 0.05. We need to know our formula for volume. Our formula for volume is length times width times height. Okay, so we're going to do 3 actual calculations here. So we're going to find our original volume. So our original volume, we are just taking the 7.4 centimeters times, let me change this, times our 12.2 centimeters times our 4.2 centimeters. Once I calculate that, that's going to get me 379.18 centimeters, and this is going to be cubed because we had 3 of them we multiplied together. Next, we're going to find our maximum. So for our maximum, we're taking our greatest possible size. So we're adding that 0.05 to each of our measurements. So we would have 7.45 centimeters for our first measurement. Next is 12.25 for our next one. And then finally 4.25 for our last. Multiply them all together, we would get 387.87 centimeters cubed. All right, finally, we're going to find our minimum. We're going to subtract the 0.05 from each of those. So we would get 7.35 centimeters, 12.15 centimeters, and 4.15 centimeters. Multiply them all together, we would get 370.61 centimeters cubed. We need to calculate our greatest possible error, so we are going to subtract the maximum and the minimum. All right, so we want to find the percent error. So to find our percent error, we're going to take our greatest possible error and we subtract the original amount. Well, to find our greatest possible error, we need to actually figure out what is the greatest possible error. So we're going to take our maximum, subtract off the original amount to find that error, and we take our minimum, subtract off the original, find that error. So we're going to take our maximum, subtract off our original. That's going to give us an error of 8.69. Take our minimum, subtract off the error. That's going to give us our error amount. Okay, so we need the greatest possible error. So that's the 8.69. So that's going to be our maximum. So we're going to take our maximum amount, the 387.87. We're going to subtract off the original amount, or I could have just taken the 8.69 from above, and we'll divide this by the original amount. Okay, so as a percent, I'm going to move my decimal place over 2. I want it as a whole percent, so I'm going to round that to 2%. Okay, if you have any questions, let me know.